Hope you all have a wonderful weekend. Today we're going to go through tangents and normals. And you see this is a mammoth exercise, there's 19 questions. The first part of it's going to be mandatory, compulsory, we're going to do it. The second part of it's going to sort of be optional extension, indicative of some of the harder problems in Year 12. And so the stuff at the end is probably the hardest stuff you'll see in the textbook, but the stuff that we begin with isn't too bad. It's just a synthesis of a number of different things that we've done before. So what we're doing is we're finding the equation of a tangent. We know tangents now. A tangent is a line that is parallel to the curve. So that means it has the same slope of the curve at that point. And so what we're going to do is we're going to find the equation of a line. Okay, so what skills are we bringing together? Well, we've got differentiation to find the slope, because we need the slope to find the equation of a line, and then the skill of finding the equation of a line. So we're bringing those two things together. A normal is a line that is perpendicular. That simply means perpendicular to the curve. So that means at 90 degrees to it. Okay, so it's going to be perpendicular to the tangent and to the curve at that point. Okay, so we're going to do both. And what we should remember is if this line has slope A on B, okay, if this line has slope A on B, then the perpendicular line has slope negative B on A. It's the negative reciprocal of, remember that from semester 1. Okay, so to find the equation of a tangent, we need two things. We need the POC, that is the point of contact. That is where the tangent touches the curve, and we need the slope. Now, in some of them, they give you the point of contact. In some of them, they only give you the x value, and you need to find the y value. So when we say point of contact, we mean an x coordinate and a y coordinate. And when we say the slope, we mean the dy and dx value given some specific x value. So let's get into our first example. It says find the equation of the tangent and normal at x is minus 3 to this function. Now, there are three processes we can do here. To begin with, we're just going to sort of perform an intuitive process. We're finding the equation of a line at x is minus 3. So I've said we need two things. We need the point of contact and the slope. Point of contact, let's find that first. Okay? So we're going to say when x is minus 3, y is going to be minus 3 squared plus 2 times minus 3. So that's 9 take 6 is minus 3. Positive 3, isn't it? Okay, so we've got the point of contact. The point of contact is x is minus 3, y is positive 3. Okay, that's where this line touches the curve. Next, we need the slope. Okay, so remember, if this is our function, we've got y equals x squared plus 2x. Then dy on dx is going to tell us the slope for any value of x. So we think back to simple differentiation. Everything is expressed as x to the power of n. We're ready to differentiate. Most of them will be pretty easy for us to differentiate typically. So this is going to go to 2x plus 2. Okay, using our rules of simple differentiation. That's what we covered on Thursday. Alright, so that's the slope function. But we want to know the slope when x is minus 3. So we'll go when x is minus 3, then dy on dx is going to be, we're going to put minus 3 into the slope function. That's minus 6 plus 2, that is minus 4. Okay, so we have everything we need. We've got the point of contact, and we have the slope. Okay, so that's the new stuff to us, okay, is finding those things. And now what we're going to do is we're going to find the equation of a line with these properties. So this takes us back to semester 1. Okay, remember the equation of a line is y equals mx plus c. M is the slope. Well, we've got the slope, it's minus 4. So the equation of this line is minus 4x plus c. And then the way we find the value of c is we input the point of contact into the equation. We've got y is positive 3, so I'm going to put positive 3 there. And we've got x is minus 3, so that's going to go there. And then we have plus c, and we're just going to solve this for c. We're going to have 3 is 12 plus c, and we get c is minus 9. So therefore, the equation of this tangent is minus 4x take 9. Okay? So that's all we're doing here, okay? And the functions we do it for are going to get more complex. But that's one of the processes we can use. That's just sort of an intuitive process. We need to find the equation of the line. Okay, next we're asked to find the equation of the normal. So I'm going to leave this up here because we're going to use most of that information as well. Just spin this one around. So the normal is going to be a line that's perpendicular to the curve. Okay, so we saw the curve, or the tangent, has a slope of -4. That's what we've seen over here. Slope is -4. That's what we calculated using dy and dx. And so the normal is going to have a negative reciprocal slope. Okay. So remember, -4 by itself is -4 on 1. So if we're going to flip that, we could write that as 1 on 4, and then it's going to be negative, negative. Okay, so if this is the slope of the tangent, then this is going to be the slope of the normal. So let's put that up. Normal slope is this. Okay, that's the slope of the curve, therefore this is going to be the slope of the normal. Alright, this has a slope -4, this has a slope positive 1 on 4. Doesn't really match the diagram. Alright, and the beauty of this, of finding the tangent and the normal, is the point of contact is the exact same. Okay, so we've got the slope, and the point of contact remains the same at -3 and 3. Okay, so we could repeat this process again. That is finding the equation of a line using Y-intercept form. But I'm going to take you back to another process that we can use as well, and that is finding the equation of the line in general form. Now, in the back of the book, most of their answers are going to be presented in general form. Remember, there's multiple ways you can express the equation of a line: Y-intercept form or general form. General form looks like this: ax plus by equals c, and ax take by is c. Okay, they're the two ways that we can express the equation of a line in general form. And the rule is, if slope is minus a on b, then it goes to ax plus by. And if the slope is positive a on b, then it goes to ax take by. So here we have a slope of 1 on 4. Okay, 1 on 4. And so my question is, which one of these does it match? All right, it's this one, because it's positive 1 on 4. So what that means is we're going to have 1 lot of x take 4 lots of y equals c. So let's write that out. 1x take 4y equals c. That's how we convert it into general form. Okay, and then in order to find c, now firstly that one, it's not necessary, but I'll put it there to show you we've got 1 at the top. Okay, so 1 lot of x take 4 lots of y. To find c, all we have to do is substitute these coordinates into this equation. So we're going to have 1 times -3 take 4 times positive 3. Okay, -3 is the x value, positive 3 is the y value. And let's evaluate this. This is going to give us -3 take 12. And we've got -15. Alright, and so that means the equation of the normal in general form is 1x take 4y equals -15. X take 4y is -15. Okay, so we've explored two processes here. I think this one pretty straightforward. We know what's going on there. Over here, we took this. We took the negative reciprocal. We've got the point of contact, and then we did the equation of a line in general form. Okay, so in the back of the book, I'm pretty sure they represent most of their answers like this. But this is one process that you could follow. If you don't like it, you can follow this process. Okay. I might just do example 2, and then maybe we can get into them, because I think it's sort of okay so far. So I'll rub this off. equation of the tangent to f of x equals the square root of x. Find the tangent at x is 4. Okay, and here they're very specific. Here it says find the tangent in y-intercept form. And then below it just says find the equation of the normal. So if it's non-specific, it means you can use either. But here it says find it in y-intercept form. Okay, so before we can go about finding the equation of tangent, we need those two things. We need the point of contact and the slope. So we've got x is 4. So when x is 4, we're going to find f of 4. We want to know the y value. Is the square root of 4? It's going to be 2. Okay? And so our point of contact is x is 4, y is 2. Got the point of contact. Next, we need the slope. Okay? So if f of x is the square root of x, and we want to find the slope function, we should remember first we need to express it as a power. That's x to the half. And then we are ready to differentiate it. That's going to go to f dash of x is half x, power of minus half. And so this is the slope function, okay? And we want to know the slope when x is 4. So we can just take 4 and put it in there into our calculator. But let's show you how we can do it manually as well. We should remember this is, it's half times x to the minus half. And x to the minus half is 1 on top of x to the half. And 1 on top of x to the half is 1 on top of the square root of x. So this simplifies to 1 on top of 2 root x. Okay, it can be simplified. And then if we go, well, what about when x is 4, the slope, or f dash of 4, would be 1 on 2 times the square root of 4. Okay, the square root of 4 is 2, so it's 1 on 2 times 2. The slope is 1 on 4. We have when x is 4, the slope is 1 on 4. All right, so if you mumbled up, well, what I've done there, you know, that simplification and putting the x in, you can just put x is 4 in your calculator. Okay? So we've got 1 on 4, so we've got the point of contact, we've got the slope. I like to make the statement right next to each other. The slope is 1 on 4. And so we're ready to go. We could perform that Y-intercept process, okay? We could go y equals mx plus c. All right, so we could go ahead and do that. Or we can do the general form process. Once you get the hang of general form, it's probably a bit easier. Okay? So let's go with general form. We've got 1 on 4. Oh, sorry, this equation does say find it in Y-intercept form, doesn't it? We're going to do it in general form. 1 on 4. So we're looking here, we're going, which one does it resemble? Okay, it's the positive one, isn't it? 1 on 4, so it's going to be 1x take 4y equals c. That's the statement I'm making from this guideline over here. Our x value is 4, so we're going to have 1 log of 4, take 4 logs of 2. Our y value is 2, and that's equal to c, so let's crunch this. We've got 4 take 8. We've got c is minus 4. And therefore the equation of this tangent in general form is x take 4y equals minus 4. Okay. Now one thing we could even do here, we've found it in general form. It wants the solution in y-intercept form. Is we can rearrange this to get it into y-intercept form. Okay, so what you should, let's do that to point out the relationship between these two. Here I've got it expressed in general form. Remember, y-intercept form is of the form y equals mx plus c. So that means I want to get y by itself. I'm trying to solve this equation to get y by itself. So the first thing we'll do is subtract x from both sides. Okay? So we're going to have minus 4y equals minus 4 take x. Right? Move that positive x over this side. And then the next thing we'll do is divide both sides by minus 4. Divide by minus 4, divide by minus 4. So here we've got minus 4 at the top and bottom, so that can cancel. we've got y. We've isolated y by itself. Over here, this can simplify. I mean, you could leave it like that, but it is a bit of a mess. So what it is let's think about it as splitting the denominator, like we've done. We've got minus 4 on minus 4. Take x on minus 4. Okay? So minus 4 divided by minus 4, that's positive 1. And minus x divided by minus 4 is just x on 4. All right. And a number of ways we could write that, right? So that's x on 4 is the same as 1 on 4 times x. Okay, and then you can just shove those terms around the other way. 1 on 4x plus 1. Now it's written in this form as an mx plus c. Okay, so we can go from general form, okay, this is one way of presenting, to Y-intercept form, which is another way of presenting it. All right, so I reckon we'll sort of pause there because we have photos after recess, don't we? So it'd be good for you guys to have a bit of a go at this. So, yeah, hopefully it's okay. You can do either of those two processes. There is a third, but I don't want to teach it to you just yet, just so we don't get confused, okay? So I want you to do either Y-intercept form or the general form process. We're just starting the questions in exercise 15B.